Hello everyone, I am Sweetie Pinjani. I welcome you to Sweetie Speaks official YouTube channel. This is System Verilog Essential series where we had covered a lot of System Verilog concepts, and today we are going to take a step ahead. We are going to perform APB transactions with whatever knowledge we gain from System Verilog. In case you have not already gone through, there are a lot of tutorials uploaded related to System Verilog by me on Sweetie Speaks official YouTube channel. You can find a lot of series. There is System Verilog tutorial series. It will give you idea of System Verilog basics and lot of data types. Then we have System Verilog Essential series where we are trying to cover some complicated System Verilog concepts which people find it hard to understand in very simple, easy language with the help of coding examples. Then we have System Verilog OOPS series. For OOPS concept, we have System Verilog randomization series. We have series on System Verilog assertions. We also have a series for System Verilog trick codes. We have System Verilog question and answer series. A lot of training material on System Verilog is already uploaded. Please take maximum benefit of it. Now, with all the knowledge which we have gained in System Verilog till now, let us perform some APB transactions. I'll explain you each and every line of the code, and then I will run the code and show you how the transactions are being performed. Let us start. The first thing is interface. Now this interface was covered in detail in System Verilog Essential series by myself, Sweetie Pinjani. On Sweetie Speaks official YouTube channel, you can find a detailed tutorial on interface. Then I also have uploaded tutorial on mod port. We had also done memory design and verification, and then also on the virtual interface. If you have not already gone through, go through those lectures. Those are the prerequisite for this. Now, let's understand how we will do the APB transactions. The first thing to understand is interface. Here, if you see, I'm creating an interface with the name of APB interface. This interface has one input signal, which is the clock signal. Clock is the 1-bit input signal. Then we have three other ports inside this interface. One is for address, then data and valid. 32-bit address is there, 32-bit write data is there, and there is a valid signal. These are the APB signals. In case you want to go through, you can go through the APB protocol. I will also cover the APB protocol in the upcoming sessions, but these are very basic signals. It's the 32-bit address, 32-bit write data and valid. Very simple to understand. Even if you don't know APB protocol, these signals are self-explanatory. Then these three signals and one input clock. This is what your interface consists of. Now, in order to give some input to the design, you will need a driver. Driver drives input to the design. That's why I'm creating a class for the driver. APB driver is the name of the class. In the virtual interface, we had learned different ways to assign value to the virtual interface. Your virtual interface is nothing but a pointer to your physical interface. Which is your physical interface? This APB if this is your physical interface. And your virtual interface will be a pointer to this. One way to assign it is through constructor. In this example, we are assigning it through constructor here. We are just declaring that there will be one virtual interface by the name APB Write VIF. The type of this interface is APB if. This is the type of the physical interface. The type of this virtual interface and physical interface should be same. So this virtual interface is of type APB if. The name is APB Write if. And inside the constructor of the class of APB driver class, you are passing an argument for the virtual interface. Now, whatever virtual interface you are getting inside your constructor, that you are assigning to this variable. If you see this is how the initialization is happening. You are taking an argument inside the constructor and you are assigning the value to your virtual interface through that argument. This is how the initialization takes place. Now this particular virtual interface is pointing to a physical interface instance of APB if. It will point to one of the instance of APB if. Next, since this is a driver, we need to drive the inputs to the design. It means we need to write some data to the design. We need to perform a write operation. For write, what are the things we will need? We need an address to which you want to write. We need the value of the data which you want to write. And the valid signal should be 1. These are the 3 requirements. Before initiating the APB write, I am just displaying that I am going to initiate the APB write on this particular address, and this will be the data value. And then whenever you have the positive edge of the clock, only then you will perform the write. So whenever there is positive edge of the clock, that time we are assigning the address write data, whatever you got in the input. This APB write task takes address and data as the input. So whatever the user wants to write the data to whatever address that we are taking as input, and we are assigning that value to our interface variable. This is my interface for the write. This is the interface I am using, and to the address variable of interface, I'll assign the address input from the user, and to the data variable of interface, I'll assign the data input from the user. And since I am performing the write operation, I'll make p-valid signal as 1. And then once the write will be performed, when you do all these things, the write will be performed, right? After that, I am displaying whatever the write was done to whatever address, whatever data that I am displaying. Then let's wait for 1 clock cycle. I want the data to be written. Before I make p-valid 0 again, p-valid should be held high till the write operation happens, and then I'll make p-valid as 0. So let's wait for 1 cycle and then I'll make p-valid as 0. At the next clock, I'll make p-valid as 0. This is my driver. The main task of the driver is to perform the APB write. Understood? It's very simple. Next, we will see the monitor. The main task of monitor should be to read your data. The driver has returned to the DUT and your monitor will read from your DUT. Our expectation is whatever data I have written, I should be able to read it. Let's understand the monitor class. This is APB monitor class. I am declaring one virtual interface for performing the read operation. The name is APB Read VIF. It is of type APB if, and then inside the constructor I am taking an argument and virtual interface argument, and whatever argument I am getting inside the constructor, that I am assigning to the APB Read VIF. This. Okay. This is how we will do the initialization of the constructor. Initialization of the interface inside the constructor. From the constructor, we are getting an virtual interface argument, and whatever virtual interface argument we are getting, we are assigning it to the virtual interface for the APB read. Now, in the driver, we had the task for performing APB write, because driver's responsibility is to drive the signals to your DUT. In case you want to understand about these verification components, in UVM, there is a series called UVM Basics uploaded on switispeaks official YouTube channel. There I have covered in detail about UVM components and UVM test bench architecture. There you will understand what is the responsibility of driver monitor. So main responsibility of driver is to drive the inputs to your design, and the main responsibility of monitor is to collect the output from your design. That is why the read function will come inside your monitor, write function will come in your driver. Now, here I am creating a task for performing APB read. When should read be happening? Only during the pause edge of clock. That's when you can do the read. Now what we will do at the pause edge of clock, let's wait for one clock cycle. We will wait for one clock cycle for all the things to be stabilized, and then we will keep on checking if p valid is 1, because you can do read operation only if it is a valid address. So whenever you have that valid address, valid signal is high, that time what we will do, we will perform a read. So here you can see we are performing a read operation. So whenever your valid is high, that time only you will check for the address and data value. Whenever your p valid is high, whatever address and data you are getting, you will display it. And finally, you have a test bench. Inside test bench, I have to first generate clock, one bit signal clock. Then I'll create an instance of APB interface. I'm naming it as APB TBVIF. It has clock as the input, one bit signal clock as the input, and I'm creating the instances of APB driver and APB monitor. And this is the clock generator. There are various ways to generate the clock. I am using this way. Next, you are having initial block, in which what you will do, you will call the constructor for your monitor. Here if you see, we are to our monitor, what we are doing, we are calling the constructor, and then we are calling the read methods. And similarly for the driver also we will do the same. We will call the constructor, and for the driver, to the write method you need to give two arguments. One is the address value and one is the data value. I am trying to perform the write to 4 different addresses. That's why I am calling this APB write 4 times to different addresses and giving different data values. Now, when you run the code, you need to observe the output. There will be 3 display statements for each transaction. One is before initiating the write, then once the write is done, and after the read is done. To the same address, same data should be written and same data should be read. That is our aim. Now let us see the output. We have written to 4 different addresses, and this is how the output got generated. To the address 1, these are the 3 statements. We are getting the same data which we have written. Same for the address 7 and same for the address 11. Same for the address C. It means our code is working properly. Our test bench is fine. And we are able to perform the APB transactions, write and read. This is you can consider it as a very simple mini project of APB protocol. If you want, what you can do, these are just 3 signals which I took from APB. Now you can try to take more signals, enhance it a little. Instead of just hard coding, you can add randomization, generate the address and data randomly. You can do coverage collection. Like this, you can make it a major project also. But at least this particular code will help you get started with APB. Understood? I will just give you a quick summary again. First is the interface. APB interface is having one input which is clock and 3 different ports. One is address, write data and valid. Then you have the APB driver which needs to drive the inputs to your design. You have a virtual interface in this. which you are assigning through the constructor. You are taking an argument inside the constructor, and whatever argument you are getting, you are assigning it to your variable, class variable APB Write VIF. Then you are having a task to do the write operation, which will take address and data as input. Before performing write, you are displaying that this is the write you are going to perform. At the passage of clock, you are taking the inputs of address and data from the user, and you are assigning it to your class variable. Whatever class inside the class virtual interface you have, you are assigning the address and data values there. And in order to perform write, your valid signal should be 1. So you are making it to 1. Then you will display that write has completed. After, you will wait for 1 clock cycle, and then you will make the valid as 0. And inside the monitor, what monitor has to do? It has to read. Again, you have a virtual interface. You are taking the argument inside the constructor, and you are assigning that argument to your class virtual interface. And then you have a task to do APB read. At the passage of clock, we will first wait for 1 clock cycle, and then whenever you get a valid, you will print whatever data and address is there, because whenever valid is there, it means you have some valid address and valid data. Then we will display it. And then you have a module for the test bench, where we will have a clock, and this is the code to generate clock. There are various ways to generate clock. I am using always. And then you are creating an instance of your interface, your driver, your monitor. You are calling the monitor constructor and read, and you are calling the driver constructor and performing 4 different write operations. Our main aim is to check whatever data we have written should be read to all 4 locations, which is being satisfied here. If you see carefully, whatever data we are writing, we are able to read. It means whatever test bench we have coded is correct. This is how we can perform APB write and read transactions. Now, understand this code thoroughly. There are how many? 4 different modules. One is interface, driver, monitor, and test bench. Understand each of these codes, interface, and then these 2 classes, driver and monitor, and 1 module for test bench. Understand these codes, and then try to code all this by yourself. If you want, as I said, you can expand it. First, try to run this basic code, then try to randomize this. Instead of hard coding, I have hard coded. You can generate it randomly by using randomization. And if you don't know randomization, I have uploaded System Verilog randomization. Complete tutorial is available in switispeaks official YouTube channel. You can go through it, learn randomization, and then apply. And then here also you can try to expand. You can try to use more APB signal, try to do some more things. Here I am just doing simple write and simple read. You can do a bulk write, bulk read, all those things you can do. But first you should have a basic understanding of this code and at least be able to code and execute this much. Then you expand. I hope you will not restrict yourself to this. You are going to do a lot more in APB. I helped you get started. I hope you will really make use of this and expand it. And in the comment section, you can tell me what is the other thing you have tried on top of this and what were your observations. And if you want me to cover any other topic in the upcoming lectures, you can let me know. And you can also provide your feedback, how you are finding these tutorials. I hope all of these are helping you. Keep on using these free resources, and to stay tuned to such quality content in VLSI, please subscribe to Sweetie Speaks official YouTube channel. I'll see you in the next video lecture. Thank you.